Okay, good morning class. So at this point we're looking at the grade 10 paper 1, the paper that you guys have written. At this point you got the paper in front of you. We have went through the paper, we've checked that every question is marked and the things adds up to the total on your page. Okay. So at this point, if you have any issues, you just let me know, you stop me and I'll try and really explain. Or if there's a question that you haven't done in class, then I can tell you where it fits in. Okay? So this paper was basically 2 hours long, 400 marks, paper 1. So the question says simplify the following. So simplify, you need to say get rid of the brackets, and your answer should contain no brackets. Okay, so we go x times x squared is x cubed. X times negative 3x is negative 3x squared. X times 1 is x. Negative 2 times x squared is negative 2x squared. Plus 6x minus 2. You all agree with that? So now we look for like terms. So negative 3x squared is a like term to negative 2x squared. X and 6x. So it's negative 5x squared plus 7x minus 2. So any issues there? No. So let's look at the next question. 1.2.2. People, there's one of two ways of doing this question. It's either I write it out twice and then multiply it out, or apply the binomial square rule. So the binomial square rule is I'm going to square the first term, which is 25x squared. Then 5x times 7y times 2 is going to give you 35, so it's 70xy plus and the last term squared, which is 7y all squared, is going to give you 49y squared. Minus, and that goes in the bracket because of that negative there. That negative must also be multiplied out. People, we don't multiply out the negative first. We must apply the exponent first. So the first term squared, of course, is going to be 9x squared. That times 2. So 3x times negative 2y is negative 6xy times 2 is negative 12xy, and the last term is squared, which is positive 4y all squared. Okay. So what do we do now? Again, get rid of the bracket. We multiply. Alright. So now going to give us 25x squared plus 70xy plus 49y squared minus 9x squared minus plus 12xy minus 4y squared. Okay. Any confusion there? What do we do thereafter? Thereafter we again add like this. Not so. So 25x squared is a like term to negative 9x squared. 70xy is a like term to 12xy. And 49y squared is a like term to negative 4y squared. So 25x squared minus 9x squared? 16x squared. 70xy plus 12xy is 82xy minus plus 45y squared. Okay. Any issues there? Again, as I said, people, that 5x plus 7y all squared, that can be written out twice, and then you do the multiplication out. It's another way of doing the same. It will take you an extra step, but you should get the right answer thereafter as well. Okay. Provided you made no mistake in your calculation. People, in 1.2, if A and B are positive, and A squared plus B squared is equal to, if A squared plus B squared is equal to 13 over 36. Then we are told that an AB is a sixth. Okay? They want you to find the value of A plus B. So what we notice is that A plus B, you got A squared plus B squared. So this is in actual fact the square root of A plus B all squared. Remember, what is the square root of A plus B all squared? A plus B. Can you see them? So I introduced that. Alright, so this now becomes a binomial square. A square, the first term becomes A squared plus the first term times the second term times 2. So it's 2AB plus last term squared, which is B squared. Again, you can write it out twice and multiply it out. People, what is a squared plus b squared equal to? 13 over 36. Not so. Plus 2. And what's the value of AB? 1 over 6. Okay. So what do we have now? So that's the square root of 13 over 36 plus 1 over 3. Your LCM, of course, is 36. So you times by 1, so it's going to be 13. We're timesing 36 by 12. So it's going to be 25 over 36, the square root thereof, which is 5 over 6. And we're looking for 5 over 6 for you to get it on that 3 marks. Okay. That is your higher order thinking question. Okay, in every exam, you should get 15% of your paper should be of this type. Okay, so make it a habit of always looking out for these type of questions. Okay, and trying something so that you can solve the question. Okay. People, let's look at the next question, which is question 2. People, the question says factorize. Now, if it says factorize, our answer should contain no bracket. Our answer should contain one term or brackets only. Okay. So to factorize this, as we can see, this is a trinomial. So we write on our product line. For 3 is 1 and 3. For 20 is 1 and 20. 2 and 10. 4 and 5. Do we add or subtract our products? We add it because the last term is positive. So that's going to give you 9, that's 23. 3 times 2 is 6. So it's going to be 10, 16. 1 times 5 is 5. That's going to be 12. What's 5 plus 12? 19. No? 17, not 19. Right, so what must we do? We must rearrange one of the set of factors. Okay. So that's going to give you 60, fairly large. That's going to give you 30, too much. That's 15 and 4. What's 15 plus 4? 19. So that's what I'm looking for. In the bracket goes 3 and a 4, and a 1 and a 5. So there's R squared, so it's R and R. There's an S squared, so it's S and S. What about our signs? Same signs. Both has to be negative. Okay. Alright, 2.2.1. You are given 8a cubed minus b cubed. People, here we got the sum of cubes. Factorize the given expression. So we factorize, so that will give you the cube root of 2a cubed is going to be 2a minus b cubed. Right? So what do we do first? Square the first term. Not so. So 2a whole squared, 4a squared. This is minus, so here goes plus. 2a times b, 2ab, and the last term squared, b squared. Okay. Then it says hence factorize completely. So what does it mean when it says hence? It means to say I must use my previous calculation. So if we look at this here, this part was already factorized into this here. Can you see that, people? So that is now going to give us 2a minus b, 4a squared plus 2ab plus b squared. What am I left with? Plus b minus 2a. Can you see that, people? But what must I do with this? Swap it around. Why do I want to swap it around? I want to look at the same like that. We swap around, what's going to happen? A negative is going to come out, not so. So it's going to be 2a minus b. So what is now common? 2a minus b. So if I take this out, what am I left with? 4a squared plus 2ab plus b squared. If I take this out, what am I left with? Negative 1. That's how you get the 3 marks. Okay. The next one, 2.3, it says simplify. So here, what do I need to do first? I need to change all the I need to factorize where I can. Not so? Let's factorize. For 4 marks. So let's factorize. That's a trinomial here. So that's going to give you x and x. Do we add or subtract our products? We add it. What about our signs? It's going to be the same sign. Both is negative. Over. 3 into x minus 1 is already factorized. That we're going to change to multiplication. Tumble and time. So that goes to the denominator. It's x minus 4. What can happen to x squared minus 9? Difference of 2 squares. So it's x plus 3, x minus 3. Times 1 over x minus 3. So now it's just a matter of cancelling out. X minus 1 cancels x minus 1. X minus 3 cancels x minus 3. X minus 4 with x minus 4. So I'm left with 3 and x plus 3. So what do we have? X plus 3 over 3. And there we go. Okay. A lot of marks involved here. Okay. Which you guys didn't want, didn't you? Given question 3.1, we are told to solve for x. So what's the first thing we need to do? Let's get rid of the brackets. So let's get rid of the brackets. It's going to be 6x minus 18 equals 6 minus 6x. So what do I do now? X is one side, numbers are the other side. So it's going to be 6x plus 6x equals 6 plus 18. So that's going to give you 20. 4 is equal to 12x. Okay. Divide by 12 both sides. X is equal to 2. Will you guys understand? Okay. Am I moving too fast? Yes. Who say yes? What's wrong with you? Okay, I'll move a bit slower. Okay. You're supposed to say many things, many things. What's wrong with you? Right, so let's look at number 3.1.2. We've got 3x squared is equal to negative 2x squared. People cannot divide both sides by x. No, I will be losing a solution. So never do you divide both sides by an unknown value. Okay, or a variable. So we're going to bring that 2x over the equal sign. It now becomes 3x squared plus 2x is equal to 0. Remember that the question paper and its memo can be found in the description box below. Okay. People, what's going to happen here? We'll take out a common factor of x. If I take that out, what am I left with? 3x plus 2 equals 0. So we set each factor equal to 0. So x is equal to 0 or 3x plus 2 is equal to 0. So you solve for x on that side. So 3 is equal to negative 2. So x is equal to negative 2 over 3. Any confusion there? No. The next one. Okay, so people, what's your LCM here? It's almost forgot, I must move slow. What is your LCM here? 6. So remember here we can drop our denominator. Okay? Why can I drop my denominator? Because I got an equation. Not so? There's an equation here. So what must this be multiplied by? 3. This must be multiplied by? 1. And this must be multiplied by? 2. So if the denominator is multiplied by 3, the numerator must be multiplied by 3 as well. So it's 3 into x minus 4. Minus. This will be multiplied by 1, so it's 1 into 2x plus 3. People, there's a common made error here. When they multiply it out immediately, then they miss out the last term here. They write the positive 3 is supposed to be negative. Okay. And of course this must be multiplied by 2. So what do I do? I get rid of the brackets. So it's going to give you 3x minus 12 minus 2x minus 3 is equal to negative 2x. X is one side, numbers the other side. So it's 3x minus 2x, as that's not going anywhere. Bring that over, becomes plus 2x is equal to plus 3 plus 12. Okay, so what do I do now? Add like this. So 3x is equal to 15 divided by 3. Therefore, x is equal to, okay. As I said, the common made error, is here when the people write positive. Okay. Okay. Let's go with the next one, people. Here we got a variable in the denominator. Okay. So what's your LCM here? LCM. X plus 3, x plus 1. Now, if there's a variable in the exponent in the denominator, of course there will be a restriction involved. So for which values of x can x not be equal to? Negative 3. Why? Because x plus 3 can't be 0. So then x cannot be equal to negative 3 and x cannot be equal to negative 1. Okay. So if the solution comes to one of those, then it can't. Then you just like draw a line to omit that solution. Okay. So what do we say? So what must this denominator be multiplied by to get the LCM? 1. So it's multiplied by 1. So it's 1 into 3 minus x. What must this be multiplied by? X plus 3. So it's 2 into x plus 3. Okay. So now what we do is solve for x. Get rid of the brackets. So it's going to be 3 minus x is equal to 2x plus 6. Okay. X is one side, numbers the other side. So minus x minus 2x is equal to 6 minus 3. 6 minus 3 is 3. Minus 3x divided by negative 3 both sides. Therefore, x is equal to negative 1. However, if you now look at this restriction on the side, what do you notice? X can't be negative 1. So now you pull a line there. And you say, therefore, no solution. Okay. So people, listen, if you don't, in future, if you don't know when to pull the line to say it's not equal, or in that case, we must omit the solution, like in here, then rather leave it so. Okay, then omitting every solution. So every time you omit a solution or put a line through an equal sign, at the wrong place you're going to lose a mark every time. You understand? So either you know when to pull the line or you don't pull the line. Like here you should have. If you didn't know, it's fine, just lose the 1 mark here, then losing the 1 mark everywhere else. You understand what I'm saying? Yes. Okay. Alright, so in question 3.2, we are given 2x minus 5 is greater than 3, but 2x minus 5 is also less than or equal to 13. Solve the given inequality. So firstly we take the numbers to one side and x's to the other side, and keep x's on one side. In this case you've got 2x must be greater than 3 plus 5, or 2x must be less than or equal to 13 plus 5. So that's going to give us 8, 2x and 18. So what do I do? How do I get x on its own? Divide by 2. So it's going to be 4 must be less than x must be less than or equal to 9. Okay. So easy. Then The question says if x is an element of integers. Again, what are integers? Here we can see integers are positive and negative whole numbers. So it's 0, 1, 2, 3, 4 all the way to infinity, and negative 1, negative 2, negative 3 all the way to infinity. Now normally when we draw the graph with a solid line, like we had, some of you had written 4 and 9, open circle at 4, close circle at 9, and you draw the solid line. When you draw this, people, then you see a 4 and a half, 4 and a quarter, all these values that lie between 4 and 5 exist there with a solid line. So if you're drawing a solid line, then that means to say that x in this case is an element of real numbers. Can you see it? However, if you're looking at integers, as I just explained on that side now, integers are positive and negative whole numbers. 1, 2, 3, 4, 5. It goes to infinity. Minus 1, minus 2, minus 3, to negative infinity. Okay. Okay, that's basically what we need to cover there. Okay. So if we draw the number line here, okay, so I must have 4, 5, 6, 7, 8, 9. We always go one in this and one more, 3 and so on. So that's your x. So if you're looking at the integers, what numbers actually lies between this? It's going to be 4, 5, 6, 7, 8 and 9. Not so. So those are the numbers I have represented. So can it be equal to 4? No. There's nothing equal sign here. So it must have an open circle. 5 will have a close, 6 will have a close, 7 close, 8, 9, 10. No. You could have left that 4 out here if you like. Okay? So that the dots represent the solution. Okay? So that's that. Amber, did you get the sum right?
No.
Oh my word. Right. So Amber walked to town at 4 kilometers per hour and ran home at 9 kilometers an hour. Okay. Do you run, Amber?
Yes.
Oh my word. Alright. So let the distance from Amber's house to town be x. Copy and complete the table. So, what was the speed she runs home at? This is supposed to have been kilometers per hour, no? So she runs from town 9 kilometers per hour. So the time she takes, remember the time is going to be distance over speed. So that's going to be x over 9. Okay. So that gets you 2 marks there, 1 for each. Okay. Then we are told to use information in the table and the fact that it took Amber 4 hours 20 minutes to get to town and back to set up an equation. Find the distance from Amber's house to town. So the distance from Amber's house to town is x. Not so, as you can see in the table. But if she takes in total 4 hours 20 minutes to get from town, from home to town and back, and that means to say I must take the time that she walks from home to town, plus the time from town to home. That gives me a total of 4 hours and 20 minutes. And remember, we're working in terms of hours, as this is kilometers per hour here. Can you see that? That is why I converted that 20 minutes to hours. Okay. Then from here it just becomes a matter of solving the equation here. Okay. So I'm just going to simplify this first a bit. That's going to give you 20 goes into here once, into here 3 times. So this can be represented as 13 over 3. Is that correct? So what's my LCM here? Okay, your biggest denominator is 9. So 4 can't go into 9. The lowest value it goes into both, which is 36. So 4 times what is 36? 9. So 9 into x plus that times by 4. So it's 4 into x is equal to. The sum is multiplied by 12. So it's 13 times 12. So 9x plus 4x is 13x is equal to 13 times 12. Or you could have given it, I think it's 156. Both sides we divide by 13, of course. That cancels. So x, of course, is equal to 12. So she lives 12 kilometers from town. Okay. You all agree with that? Right. Nice question to understand. Then again, all questions is nice to understand. Eh? People, let's look at number 4, 4.1. Okay, so 4.1.1 solve for k. People, what's your LCM here? K. LCM is k. So that must be multiplied by k. So it's k times k. Plus that must be multiplied by 1. That's natural over 1. That must be multiplied by k. So it's going to give you k squared plus 12 is equal to 7. Take it over the equal sign. Comes a quadratic equation. So k squared minus 7k plus 12 is equal to 0. Trinomial. So k and k, 4 and 3, minus minus. Okay, so k is equal to 4, or k is equal to 3. Okay, many of you got that question right. But coming to this one, what you should note here is that, see the thing is off here? Okay, what's going on now? People, if it says if k is equal to 4. Now I know some of you got your own Mickey Mouse answers and then you use that answer. No. You see here, even if you got a different answer and they tell you if k is equal to 4, then you must not use anything other than 4. Can you see that? If k is equal to 4, hence or otherwise solve for x. So if k is equal to 4, people, then this value here is actually 4. Can you see that? That is 4 and this is 4. But if I do a comparison, say, hang on, what is on k's place? K is actually equal to 3x squared plus 2x plus 3. Look here, there's k. What's on k's place? 3x squared plus 2x plus 3. Okay, so there's actually a link between k and that trinomial. You see that? So then what can we then conclude? If k is equal to 4 and k is equal to 3x squared plus 2x plus 3, then 3x squared plus 2x plus 3 is then indeed equal to 4. Now it is a matter of solving the trinomial. Take it over the equal sign. So 3k squared plus 3x squared plus 2x minus 1 is equal to 0. So what is this now to us? Trinomial, of course, is a trinomial. You can factorize. So it gives you 3x and x, 1 and 1, plus minus. So 3x is equal to 1, so x is equal to a third. or x is equal to negative. Okay? Understand? That gives you a nice healthy 4 marks there. People, our favorite simultaneous equations? Okay, settle down. Of course, there's 2 ways of doing it. I can either use the elimination method or I'm going to use the substitution method. Whichever method you use, it's fine. Okay? I'm going to use the elimination and substitution method. So take it over the equal sign. B is then equal to 69 minus 3a. And this is equation 1, equation 2. Or you could have called the first one equation 1 and then the new equation, equation 2, it doesn't really matter. So what do? We substitute equation 1 into equation 2. So wherever I see a B, I replace it with 69 minus 3a. So my equation now reads 2 into 69 minus 3a plus a equals 38. So what do I do now? The brackets. Not so. So 2 times 69 is 138 minus 6a plus a is equal to 38. A is on one side, numbers the other side, so it's negative 5a is equal to 38 minus 138 is negative 100. So a works out to be 20. So what do we do with that? We sub that back into equation 1. We already have b as the subject of the formula. So b is equal to 69 minus 3 times 20. 3 times 20 of course is 60. And then 69 minus 60 is going to be 9. Okay. Am I moving slow enough for your liking? Okay, good. Okay, any other confusion here? Okay. In 4.2, you are asked to make in the subject of the formula. Okay, so what do we have to do first? Get rid of the bracket, the denominator, not so. So I'm going to multiply both sides by 10, or I cross multiply because I've got a fraction on either side. So 10k is equal to p into the square root of n plus 1. People, there's many ways of doing this. Okay. So what do I do now? Sorry? Divide by p, or you could have squared both sides. Okay. So that's gone. So the square root of n plus 1 is equal to 10k. Now what? Over p. Sorry? Square both sides to get rid of the square root. So it's n plus 1 is equal to 100k squared over p squared. Now what? Minus, take a 1 over. Or I could have left it as that is there. So n is equal to 100k squared over p squared minus. Okay. You can go a step further and find p squared as your LCM and then say it's going to be 100k squared minus p squared over p squared, and you can take difference up to, but for no extra marks. Okay. We have made n stand on each other. That's what you are marked on. Okay. And there's a question say make n the subject of the formula and simplify. Then you'd have to go a bit further. Okay. Here we are told hence or other one. People, if they say hence, what does that mean? Use the previous calculation. Okay. Why are you shaking your head? Alright, so let's just do this quickly before we pack up.
Your attention please.
Otherwise?
Can the following learners please report to the office? Kendall Solomons, Rochelle Williams, Novia Tofile, Ikona Ruka, Imangel Unake, Kiara Johnson, and Flumena Nukozela. Those learners, can you please report to the office?
Okay, so ensure otherwise determine the value of if k is equal to 12 and 7 over 16, and if p is equal to 5,63 times 10 squared. Round up to 3 decimal places. Okay, so in our next lesson, we will start with the sum. Good morning, children. This every day. Good morning, class.